All right, welcome to the Network Plumbing Working Group meeting, May 20th, 2021. Kicking it off with the regular business. It doesn't look like we have any new member candidates, maintainer candidates, or candidate projects. And it looks like we have a lot of familiar faces on the call. So thank you all for joining. I appreciate it. Jan and Perry, do you guys want to kick it off with VLAN trunking?
Yeah, sure. This is Jan speaking. Can you hear me?
Yeah, I can hear you, Jan. Hello.
Okay, great. So can I share 2 slides? I guess I can, right?
Yeah, let me know if you have, if it doesn't allow
Host
you.
disabled attendee screen sharing, it says. So
okay, let me figure out where to that. All right, give it another shot.
Yeah, it looks better.
It looks good on my end.
Okay, I have entered full screen mode. I don't know if you can see that, but if not, then I guess it's good enough. So what we want to present today, Peri and myself, is the question of how we can improve the support that we have in Multus with OVS CNI for trunk interfaces, trunk secondary network attachments that are actually VLAN trunks. And let me start with the status quo that we have with OVS CNI today. OVS CNI, basically, when it comes to the kernel interfaces, supports 2 types of kernel interfaces. One is access interfaces, like Net1 here, which are through a VTH pair connected to a tagged port in OVS, so that OVS takes care of the VLAN tag removal or insertion, and the application in the pod sees untagged traffic. And for this kind of simple access network attachments, IPAM is fully supported, meaning OVS CNI can interwork with IPAM modules like whereabouts and then configure the injected interface with the IP address and other information like MTU size and routes and stuff. And then we have the second type of interface, which we call OVS calls trunk interfaces. We have transparent trunk interfaces where basically all the VLANs that exist in the bridge in OVS are exposed to the pod. More relevant are the selective trunk interfaces where we specify which of the allowed list of VLANs are exposed to the pod. And then the pod sees VLAN tag traffic on the parent interface Net2 that is injected. And for these trunk interfaces today, there is no support for any IPAM, obviously, because the parent interface is not really the interface that should have IPAM. There should be VLAN sub interfaces, for example, and those VLAN sub interfaces would then have to be configured with IP addresses. So the support exists for selective trunks, but only very bare. And this has been good enough for the first application that we were targeting, which was basically dealing with the raw packet sockets here, or even with DPDK interfaces, and doing all the VLAN handling and IP address management themselves. But there are other applications, and the proposal that we have here today is to suggest how we can support such applications with the creation of VLAN trunk interface, VLAN sub interfaces, and IP address management for those. So basically, the suggestion is that on top of what OVS CNI supports today, We also support the creation of VLAN subinterfaces and IP address management for those as part of the OVS CNI. And in order to do that, the proposal is to enhance the OVS CNI configuration with optional IPAM configuration for every trunked VLAN. And if there is such IPAM configuration present, then the OVS CNI plugin would invoke IPAM several times, one for every trunk VLAN that has such IPAM config. Optionally, the CNI plugin could then create VLAN subinterfaces on the parent interface and inject them into the pod namespace and apply the IPAM configuration that was received from the IPAM module, if available. And then eventually, the OVS CNI plugin would return information about all the configured pod interfaces, the parent and the trunk VLAN subinterfaces, to Multus, and Multus would include that data in the network status list, so that a pod that relies on network status annotation could actually make use of that. That is the high-level proposal, and Perry has implemented a POC with the necessary enhancement in OVS CNI and 2 small changes in Multus and the net attached definition client to demonstrate how this could work.
So I can understand.
So Perry, do you want to?
I can understand the need for lagging, but I don't understand why the number of networks would. You say that you need to do. Okay, you want to do that VLAN trunking, that you need lags in order to do VLAN trunking. I don't see it. I can understand it for HA. I can understand it for bandwidth, but not to have anything to do with the number of networks it puts on top.
Yeah, I haven't talked about link aggregation here at all. I mean, on the physical interfaces, you probably have link aggregation, but that is not related to what we're discussing today. Let me go back to this slide. So why we have introduced this?
I see what I've misunderstood.
Why we have introduced this in the first place was that we have applications that actually need access to not only tens, but hundreds of external networks. In the 5G core and IMS arena. And it's simply impractical to inject that many access interfaces into a pod. And even if we would do that, it becomes impractical for OVS to handle that many ports. So, and then we also need a certain dynamicity. So to be able to add and remove additional VLANs during the lifetime of the cluster or the application or both. That's much easier to do with trunk interfaces.
To handle the VLAN, to do the separation inside.
Yes.
You're talking UDP in reality and running your own stack. And I guess in reality, you would want to have a DPDK under this OVS in many cases if you can. Okay, I see what you.
Yeah, I mean there is a DPDK flavor of this, yes, and for that this discussion is not so relevant. But we have also control plane applications that are not DPDK applications.
That you want to have a sim. You want to run a raw socket or pretty much and take full.
Yeah, that is what they do. Exactly. That is what they need to do today, to run a raw packet socket on the parent interface and do all the VLAN handling themselves.
Yeah.
Right? And that works.
Yeah.
And all the IP address management. But if you have an application that is not prepared to do that or doesn't want to do it,
so when you say,
then what is needed is
you want
basically
to have VLAN sub interfaces on net 2. I mean net:10 and so on, or
yes.
Okay. So you want to have a
and we want to automate the setup of these VLAN sub interfaces and IP address assigner for those.
Okay. Perfect. Yes, I understand what you want. Yes, I can understand the need. Thanks for the clarification.
Okay. So yeah, great. Peri, are you able to share?
Yeah, let me try. 1 second.
Okay, then I will stop sharing now.
Yeah, sure. Okay, now let me try. Yeah, looks I have problem in sharing. So can you just try to run that Ask Kinema recording so that I
Okay,
can
I'm not prepared for doing that, but let me quickly try.
Okay.
Oh, where was it? Just give me a second. Then this might work, but it might be a little bit. No, I can make it bigger. Okay, that's good.
Okay.
So let me. So I'll start sharing again. Okay.
Yeah, thanks, Jan. Yeah, actually for this use case, I just created a small demo. So I just recorded with Ask Kinema. So let us play that. So actually, so I just have done it with the single node cluster, which is installed with Multus and OVS CNI with all the required code changes in both the components. So I'm just having this single node cluster and having all the softwares installed. So now let us look at the network attachment definition and the pod examples. Yes, so this is the network attachment definition, like so which is having the trunk config, which are available with two VLAN IDs, 42 and 50, and each VLAN is having its own IPAM config. So which means like this is going to create three interfaces, net1 and net1.42 and net1.50, and each interface is going to configure with those IP addresses. And this is the pod spec. So it is having this network annotation that OVS CNI net. Now let us create that pod.
I'm not sure if this is a problem to everyone, but I cannot see very well the share screen. Okay, it's a bit limited, I would say.
I can try to make it bigger.
No, this is too big. Right now it's better. Okay, thanks.
Okay.
So now let us look at the IF config on that pod. So now we can see all three interfaces, parent as well as the VLAN sub interfaces, and also it's configured with the proper IP addresses. We also have the right subnet routes being configured inside the pod container. Now let us look at the network status for the pod.
So who created the sub interfaces in the pod? This
That
case.
is done by OVS CNI.
Okay,
So
okay. So the OVS CNI would create the sub interfaces and call IPAM on them.
Yes. For each sub interface, it invokes the IPAM.
And each sub interface represents a different network. Although
it's part of same network. But
no. They are different networks. They are trunk networks on the same trunk. So they are part of the same network attachment definition file.
Yeah, that is correct.
But
from Malta's perspective, like it's from the same network, like that is OVS CNI net. So because we are having single network attachment definition, right? So
we have a network of networks.
It's one network attachment definition covering multiple networks being attached as a trunk simultaneously.
Yeah, correct. Yeah.
And that was possible before, but what we are adding now is basically the possibility to create the internal pod internal VLAN sub interfaces and do IPAM for them.
And
that was not possible before.
And like the network attachment definition, and Multus needs to be now aware of that single interface has multiple networks.
Yeah, actually from OVSCNI, like so when it's going to return the result, so which is going to return with multiple interfaces with the IPs. Then from Multus perspective, like we just need to build the right network status. So based on the result returned from the OVSCNI. So right now, like it's handling single interface, but maybe we need to take care of all the interfaces being returned from this result object.
So the result of a CMD add command yields like multiple network, network statuses, correct? That's the, I mean, in regards to if we look at the implications on.
Yeah, actually the delegate CNI will return the result object back to Multus. The Multus is going to invoke the create network status. The create network status API is going to return array of network status object. So with that, like it's going to build this network status annotation for the pod. So normally, like if you don't have that change in the create network status, so you might have like single network name that is default OVSCNI net. Then you might have interface being set to net1.50, so which will set to the last interface. Then if you look at the IPs, it is going to have all the IP addresses. So you won't have like array of network status for each interface. So that was the problem we have.
Yeah,
seen.
I think that is the change. That is the change that is needed. That Multus is basically prepared to receive a list of results from the delegate CNI, that it translates into a list or an array of network status that it then appends to the network status list, rather than having hard-coded only a single one.
Gotcha.
That is roughly the change.
So it's like, go ahead.
Yeah,
Go ahead.
Yeah, actually from the delegate CNI, that is OVSCNI, so that is anyway going to return just result object. So in the result, like you can have like list of interfaces, list of IPs. In the IP, like you'll have like IP to IF index, so that it can correlate the IP to specific interface. Then on the Multus, we are going to build the network status based on this result. So in the create network status, we might need changes. Not in the delegate.
So there is no change in the actual. There is no change in the actual return type of the CNI, right?
Correct. Yeah, correct. Yeah.
It's just that the interpretation of that is in Multus, when creating network status out of it, needs to be adjusted slightly. Correct?
Correct.
So, hey, can you hear me?
Yeah.
Okay.
Yes.
So I have yeah, as you mentioned, that you do not changing the return result object, the structure point of view, but this drastically changes the semantics of the result object. So currently for each network attachment definition showing the one network, I mean that this contains the one net IP address space, and then this network means the how do I say, splits into the broadcast domain stuff. So your configuration is changing. One network attachment definition may have multiple network. So so currently the network multi-network policy, we are the multi-network policy is based on the assumption that one network showing one network definition is showing the one network. So this is so currently this is not they're following the your stuff. And then also regarding, so currently the one network attachment, so and also the how do I say, so result object, the we can easily identifying the how do I say, network by the name, but in your case, one network attachment definition name, I mean that in this case, the default OBS CNI net have the multiple. So we do not identify which network based on their name. So that this is also the broken our architecture. And then also we need to check the multi-network spec because we also have some this we made something written related to this design. And then also I have the question about the stuff is so currently some meta plugin. Let's imagine that the tuning or Mac the plugin, or maybe I could say the route override CNI. So this stuff is only change is based on the the first interface is to the container, and the second and the third is not to go to. So in this case, the OBS CNI does not support these meta plugins. So it's it's pretty unique stuff. And then some.
No, then what is the reason like the result object is containing like array of interfaces? Because the result object like can have multiple interfaces, multiple IP addresses.
So for example, in this some case like the PTP. So I only know the multiple interface is the maybe the mainly the PTP. Maybe the bridge is also, but I don't remember correctly. But at least the PTP returns the two interface. The first is to the container side, and the second is container host side. So at that
basically
time,
like in this case, when we say like there's a multiple networks, it's not from Kubernetes.
No. So this one network in so in this case, when the PTP returns the two objects, both interface is in the same network, right? So one PTP means the virtual Ethernet. This is the point-to-point. So the one pair, one interface goes to the container side, and the other thing goes to the container host side. So the both IP address is in the same network, right? Because this is just a
okay.
So so I'm just wondering that you're changing, as you mentioned, that this doesn't changing the structure, but from the semantics point of view, this may not only the need to be changing the multi-network spec, and also the CNI specification is also need to be changed. So I'm a little bit concerned this stuff because the Maltus, so currently the Maltus, so even though the CNI doesn't support it, there are multiple interface, but the Maltus is trying to following the CNI specification and the CNI structure stuff. And then maybe that's why the lots of challenges is still in the stuff. And then also so the Maltus team is working closely into the CNI community and then try to fixing the several stuff. And then some of them should be addressed in the CNI 2.0 stuff, maybe. So they are that. So that's the stuff. So, and then also as previously, I don't remember when it is, but at least 2 years or 3 years, we have some discussion, similar stuff. I mean that the multiple interface result, multiple interface in the one result. At that time, as far as I remember, the Dan Williams. So today, we don't have the but today he is also they have some concerns for that, and then the that stuff. So I don't remember the correctly, but so that maybe the how do I say, maybe the next meeting there we'd like to we could ask
No, actually,
Williams
no,
about that.
No, if you're really concerned about the name, like what we are showing in this network status, maybe we can easily change it, right? Like.
So, but
Yeah,
also
but clearly,
as I mentioned,
I believe the concerns are absolutely valid, and that's why we are coming here to discuss this.
Okay.
I mean, we are trying to solve a use case that we have, and this may not be the best possible way of solving it. It's one way that we have seen that could work, but I tend to agree with you, Tomo, that this probably touches the semantics of the CNI spec and the multi network spec, and we need to be very careful, right? I totally agree with you here. But we have basically already in the past decided, when this was integrated into OVS CNI in the first place without IPAM, to support something like trunk network attachments. And if you look at SRIV, that is an absolutely normal use case, that an SRIV virtual function in transparent mode basically
then CNI
is
doesn't
injected
see
into
it.
pod and carry.
CNI never sees it.
The CNI doesn't see it. That's correct. That's correct. But it's a single network attachment that provides access to many networks in parallel.
Absolutely. But I mean, what you're saying is that, so if you look underneath, so we have our own vSwitch and we doesn't use OVS, but you have a number of networks. Doesn't matter how they're presented to this one. It can be, in reality, you should be able to do VLAN tagging in the best of case. You want to present to the pod a number of networks, let's say X, and you want to use one sort of base interface and you want the other ones to be child VLAN based interfaces. You want to map them up there. And then in the pod, of course, you get different attachment points. I mean, you get addresses on different interfaces. Because that's what you're doing, right? You get a .42 network and so on in the pod.
Correct.
Yeah. And so why would the pod, I mean, so this is then, why would a sort of a Go pod care? I mean, it sees an interface that they use. It doesn't care if it's called net 142 or net 1 and net 2, right?
That's true. A Go pod wouldn't care when consuming those interfaces. That it doesn't make a big difference. But for the infrastructure, it makes a big difference.
Which infrastructure?
The one that provides the Kubernetes cluster infrastructure, including the vSwitch or whatever is running there, that provides
I think what you're really saying is that for OVS, this is an OVS, because I can't see the Linux kernel really caring if it's call it a primary or a VLAN based interface. To me, it seems more like this is then limitation in OVS, and as an optimization, this is a good way to get around the limitation you have in OVS. Am I correct in that? And I have no problem with the behavior. I just sort of want to understand why.
I don't know if I don't know if I would call it a limitation in OVS. I mean, it makes a big difference for the host network handling configuration if you have a single interface that you inject, or you basically split up the VLANs on very many and then inject and write network attachment definitions for those very many. So it's a big difference, I would say. From an infrastructure network provisioning management perspective.
Well, for me, a network is a network, okay. Right? But if you say so, I don't see why I would doubt you. But because I think that what's important is to keep the abstractions clean, and I don't see really the. So yeah, so because on the spec level, right, this is just networks. I mean, they have different name, right? No, they're all tied to the same network. That's the problem. And then you create different interfaces on this network. Okay, I'll see what Tomo is.
They are tied to a network attachment definition, which in my view of the world is not identical to a network.
I think that is that's what Tomo. Yes, that's what you're saying, right? That definition is the network.
Can we use it as equivalent to OpenStack? Like the network attachment definition is what we have as network in OpenStack. In other one network, you can create like multiple subnets. So can we see it this way, maybe?
Well, when you
Is it
say
possible
subnets, you mean L3 networks?
Yeah, I mean, here it's not just L3 because you
the
just
network
open.
attachment, it really creates the layer 2, right? Or sort of the layer 2 stitching attachment, and on top of that,
Yeah.
layer 3s. And
Yeah.
VLANs
Yeah.
are
The analogy to OpenStack is goes only so far, right? Because
Yeah.
in OpenStack you have a neutron network, and then you create neutron ports on it, and the neutron ports can be of different types, VNIC types like normal and SRIV and so on. Whereas here you have multiple network attachment definitions for the same network normally, not looking at trunking. Providing different kind of network attachments, like an SRV network attachment or a kernel network attachment. And depending on the CNI that actually provides it, there are even different ones. So the analogy is anyway not very clear. But here we are really talking about VLAN trunking and subports basically. And there is no such thing currently modeling this in the network plumbing multi-net spec.
But so if you turn around and say that you're the infrastructure, and now I'm in the switch, right? A switch doesn't care. It's a network, and it's sort of the encapsulation is using VLANs. It could come as a VXLAN or Genève or MPLS or any other encapsulation, right? It's just a network, and then you have hardware or software that reacts and can balance these networks. So they're all networks. So what you're looking at here is what you said before. It's a simpler way to manage these networks because they are separate networks.
Yes, exactly. Exactly. A simple way of dynamically managing those networks without having to create lots of network attachment definitions all the time and having a variable number of network interfaces to inject into a pod. Those kind of questions.
You want to be able to use the network attachment definition as a factory and sort of specify a family of networks. Tomo and
yes.
And
Yeah.
If you can put it like this, I mean, yes, instead of having in your network annotations in a pod to list 400 networks, you just refer to one. That is the trunk that contains all the 400. And if during the lifetime of the cluster, 10 networks need to be added because there are new APNs created in the world, and you need to connect multiple new enterprises, then you just add them to the network attachment definition and restart the pod, and then you get it.
So you want to create a higher order object that is a collection of networks and their VNIs and treat this as something that gets attached together. Because you wouldn't attach just one of these internal networks to a port. You want to attach all the networks that goes in the trunk. So basically have a trunk definition. That's what you say.
Yep. But I mean, that is what we are doing already today, both for SRIV as well as for OVS-CNI, except that we today don't have any support in OVS-CNI to go into the pod and create, when wanted, create VLAN sub-interfaces and do IPAM for them.
So if you would generalize this, then it's then you want to be able to have a group of networks and sort of treat them as a unit when it comes to scheduling.
Correct.
Yeah, that's definitely not in the CNI today. Tomo, is this something that we should try to push in CNI too, or?
So at least they are currently the network network prompting working group, the multi-network spec does not, maybe that we need to be changed, but before that, of course, the CNI is also the target to be discussed, because I suppose so now I don't read the CNI spec completely. I don't remember the completely yet, of course. So we need to you need to check the CNI spec, and then also if your design is not following the CNI specification, then you need to change it. So so currently the network, of course, so the multi-network space is based on the CNI spec. So because the multi, and then I don't know how to proceed in
what
the
was said
CNI.
about easing the management, I get what that was said there. That's yeah. So we would. Yeah, so it would sort of add a layer of network orchestration into this and not just talk about single networks. Yeah.
But I think also there's new concept here, like the relationship between kind of parent and child L2s. Like those trunk, they belong to a single port. You could see similarity, let's say, on the bounding interfaces.
Yeah, if you start talking about termination points, absolutely. It's a group of L2s that get attached together on the same layer 1 termination point, right?
I see we want to create multiple one, but you could take it in different perspective. You could say instead of having a factory in a code, you could use some tooling to provision those to provision multi-attachment, right?
So maybe
but you can't get dynamicity there without updating all the pod specs all the time with adding and removing network annotations in order to get access to fewer networks.
How are you getting dynamicity here? You are mapping essentially eventually all of these VLANs to subinterfaces in the pods. You just said you are creating these interfaces.
Yeah, but
by the CNI.
Exactly.
So they are created. So
assume
yeah.
Assume we go back to the network attachment definition here, right? We update it, add another ID 6062 with IPAM, right? So we add a VLAN to the trunk. That doesn't change anything. It just changes the network attachment definition. But as soon as we restart the pod, it will be created. It will be starting up, and it will have get all three.
Yeah,
you would have then created a new network.
It's what,
I mean, that's
is that you have a grouping. Forget that it says trunk, right? So you have a grouping that groups two networks together as something that should be scheduled together. And then you happen to use VLAN right now. You could have used VXLAN or whatever to separate them, right? So I understand what you're doing, but I wouldn't want to tie it from a spec level just to VLANs. You should be able to do this with any sort of network identifier, group things together and say this sort of physical interface, and then it's up to the other side if it can handle this.
The use case here is VLAN tagging on for OVS CNI. There might be other CNIs with other vSwitches beneath that would do other encapsulation and. But yes, what we're after here would be a generalization of the spec, if needed, of the specs, CNI and multi-network spec, to make sure that a single CNI, basically plumbing one parent interface into a pod, can return more than one, let's say, network interface.
So you want in the pod just to be able to say,
to Multus, and through Multus to the pod into the network status. That is basically it. Whether this is a VLAN or something else doesn't really matter.
So you want in the pod attachment annotation to just be able to specify the name there and get all the trunk. I mean, all the networks attached.
Yeah, that's what we're doing, right? The pod says I want OVS CNI net, and it gets basically everything that is trunk there.
Can you go back down to the status, the network status that's returned?
Yes, it's here.
I mean, I think part of the issue is that, I mean, the main issue is that you're calling the command add and you're getting multiple interfaces back. If for like net one, I mean, just in the structure, is it possible to add like sub interface, which is of type, the original type, and then that way you know, net one could then have sub interfaces of net 1.42.50. Would you say 62 or whatever this added? And then who knows, in the future, maybe there's some other sub off of that if you needed to. So you're still returning one status, but now it's, you know, the data is being returned. So the CNI, but it's under one structure. So the CNI sees one interface coming back.
I think that is probably the more sound modeling approach.
I mean, it would be a spec change, but I mean, it may be the right way to go.
Yeah, I put down as a similar question. Yeah, what if we had some sub interfaces field and yeah, we embed these results to kind of pack it together into something that Multis could parse. And then that way we don't change the semantics of this object as much. And maybe it doesn't fly in the face of this CNI result. I also just want to give a thank you to you guys for putting together the presentation and bringing this.
So I think there's one thing I would change, and it's nothing with this, but I would specify the use case. And this is so for CNFs to be able to sort of make it bearable to do the manifest and so on. And not, I mean, less error prone by having one thing you add in the annotation and sort of not forgetting 2 out of 40 or something like that. And that's how I would come in with it and sort of not push to say this is for OVS. Sort of this is a need that's there for a group of users that is very network centric, and that need exists for everyone. It exists for Kaloom and our customers for sure, and others. And I sympathize with sort of what's trying to be done, and I like it. And then sort of how it gets delivered up into the pod, if it's at a dot or if it's a separate interface, depending on the technology underneath, right? That's really, to me, technology. But what's interesting is from a user perspective, that I have a way to group networks, and then I have a way to use the group name for those networks and sort of to minimize the management, let's say, errors and simplicity. I think that's the important thing. I think that's the wider use case.
So these still need to be defined somewhere, right?
Yeah.
But just a question, right? So let's say we had, instead of one network attachment definition, you know, having n networks as sub-interfaces, having like n network attachment definitions, and sort of like relying on an admission controller to given a configuration or a mapping of this group to inject those automatically into the pod spec before creation.
Yeah, sort of.
So it's like we still keep the fact that is one network attachment definition per network, and the management perspective is automated, given a predefined mapping by which it will be done by like an admission controller for that.
Yeah, that would work for the specific case that the application is actually able to consume, let's say, 400 interfaces with untagged traffic each. But as I said before, this is in production use today without the IPAM part and without the creation of the VLAN subinterfaces with DPDK applications and other applications that are using raw packet sockets on the parent interface and handling the VLANs internally, and they rely on the trunking. So the trunking of networks on a single interface, that's absolutely crucial. And many applications, it's not equivalent.
So when you do SRV, right, you do a VLAN in VLAN tag, and you shoot it off, and the Kubernetes is not aware at all. Because the virtual function will script.
But even without SRV, with the OVS today, we have that. The applications are running on top of that. Yeah.
No, I think my perspective is that, yes, this is clearly use cases we should look at, and this is one way to solve it. But I'm really happy that you brought up the use case. And for anyone working with networking.
So what do you suggest as the way forward? how shall we form kind of?
Well, you shouldn't listen on me for suggestions. So if I talk person for me, I think to be able to generalize this and specify the behavior as part of Multus, and because to me, Multus is so dominant that for any secondary interface, that's what's there. Personally, I don't really care what it says in the CNI specs. I care what it says in what the plumbing working group has said, that's how secondary interfaces work. And I do think we need a grouping. How it's done specifically for OVS and how it's done for our switch KVS, I don't really care about. We need to be able to specify it and give the applications what they need. Because I don't. Does your applications really care if it says net.42 or if it says net1234 in the pod? I can understand the management that you want to put it like this and deliver it as a VLAN. But what the interface is called, does it matter? Because they don't want to see the VLAN tag, right? They just want to see a network with the IP addresses on and separated when it enters the container. In this case, the way you set it up.
I think it matters.
You need to have some indication what network this is.
No, for sure. So you say
only the IP address is not enough.
Okay, so you want to encode VNI information in the name, and that's what the .42. I think that, well, Abdallah is the one who should talk to this. We ended up hashing our interface names because we support so many networks and so many attachments that the 15 characters that you have to express this wasn't enough. And what if you want the same network twice, right? So the idea to encode VNIs into the interface name, I think is, I mean, if someone does it, yes, sure, but it's dangerous.
And also, I think like in your previous question, it matters if it is like with the dot notation, because right now, today, even before this POC implementation, if you want to have a selective trunk and use OVS CNI, you will get like one selective trunk interface in OVS that is attached to a pod, and then you create sub interfaces on that trunk interface. If you don't have this dot notation and you want like net1, net2, net3, that means that those are going to be like different interfaces that are going to be attached on the OVS switch.
Yeah, but I can understand it's on the OVS side, it gets different.
On the OVS side, this is a single port, like with the.
In the pod, it's not really different. It's just an interface.
You mean you still create support interfaces, but you don't use a dot notation.
No,
so it's not like
if it's a dot notation or not. Once you're consuming the interface and the socket, couldn't care less, right? It's the IP stack that handles that for you.
Okay. But what you need to have is some unique tagging of the interfaces in the network status, so that you know which interface is what, right? That you need.
Yeah,
what that is application specific, I guess. So what we have done here is just an example that is something that can be easily kind of hard coded.
I mean, in reality, if you want meta information.
If you want to have a different naming, like
because the user names networks, right, and so on. So
yes, so you would probably have a name in the trunk, in the trunk spec here, in the network attachment definition.
Yes.
Yeah.
So
here you can specify the interface name to use.
Exactly. But we have no simple way for a non-Kubernetes aware container to find this name based on something. So you want a way to link the model so that the application understands which network it is when it sees the interfaces. I mean, when it sees what's in its namespace. And
the way is that the application comes and says, I need access to X number of networks referred to in their virtual link descriptors. And then somebody goes and creates a network attachment definition, like trunking all these networks on an OVS trunk, for example. But the names that are specified by the application can be put into the network attachment definition, so the application can basically recognize those network interface names, and they know what it is. So I think this would work. Yeah. So only in case that no name is specified, the OVS CNI prototype that Piri has done now just picks the .42 or .50.
Yeah.
But
Yeah,
it can be overwritten by the application designer
Yeah.
or the person who writes the network attachment definition.
Yes,
All
and
right, I hate to interrupt here quick, but seeing that we have 5 minutes left and this has been a really fruitful conversation, and again, just a thanks for presenting this and for the conversation. I just want to take a look at what we can line up as some next steps so we can keep this conversation rolling. Some of the things I wrote down as a possible next steps is number one is to outline the use case in some generic terms. It looks like, you know, we have a few cases here that this would apply to. That's kind of this like grouping of sub interfaces. Another possibility I wrote down is that we could present this problem to the CNI maintainers themselves. I think that it's an interesting problem. I think that it would be to our group's benefit to make them aware of this so that it can be considered in the current spec, and especially as it plays into the CNI version 2. But last but not least is, how can we reconcile this problem with the current state of the CNI spec and what we can do in our multi-net spec in order to accommodate this? And I also wrote down, you know, what Billy was highlighting, which is this idea, can we, you know, pack this into results and make it as an additional field in these objects that appear in the network status list. What does everyone think about those possible next steps, and or is there anything else we want to add to these possible steps?
I agree with what you said, Doug, and I'm sort of, I'm sorry if I came across as aggressive. I really think this is worth looking into. I don't understand why I haven't thought about this before, sort of to group things together like this.
No, it's awesome. And when I hear somebody possibly being aggressive, which I didn't interpret that way, I see it as excitement, and it's good that we brought it up. Yeah.
I don't know if the other guys sort of had worked with me before. We were working so long together now, but yes, I do think, and I also think sort of that as a general problem, sort of how can anyone runs in a Kubernetes pod, because then we don't have this problem with just one interface, right? But how do you map the interface in the namespace to something that makes sense for the application? Can we come up with some solution for this metadata we put somewhere, or a service where you can go and ask? I don't know, but I find it very, very worthwhile to look at.
Yeah.
Yeah.
So
Sorry.
So go ahead. Go ahead. First.
Okay, I was going to say, we ran into this with the device info spec, where we tried to pass additional information into the pod to help identify. And the only thing we had at the moment was like the network name, which isn't ideal. We were looking for some type of additional metadata to kind of identify which additional interface was associated with which network, to kind of let the application know, you know, how to use it. So, I mean, right now, that's the only thing that we had. So anything additional would be great.
So from myself, I'm pretty happy to hear this the proposal because this shows that the not only us, there are many others, they are using the network attached definition, and then also they're finding that something that is not covered yet. So so currently the as you mentioned, maybe some of the use cases they'd like to create the multiple network in their structure, and then from the how do I say, or so maybe I'm just wondering that maybe we may introduce the new CLD which generate or some the multiple stuff, or I don't thinking deeply yet, of course. So I'm just come up with something stuff. But totally this could be the changes of the our CLD stuff, and then also the ecosystem. I mean that the so currently the neural models, also the modes network policy, and then in the future we also address in the service abstraction. So the and then the Euro proposal is enriching these stuff, and then there also the provides the users to use our stuff in the various ways. So
I mean, there is a similar but slightly different problem that we should look at. Let's say that you wanted to steer these networks up in the trunk, but on the receiving side, you did not want to have the sub-interfaces. You wanted to consume the raw VLANs. Be able to specify that would be nice.
Yeah, that is possible, like as part of the network attachment definition.
You can do that today, yes.
Yeah, in the trunk parameter, you can specify all the options, whether you want to create VLAN sub-interface or not.
Okay.
So right now we are not doing that.
In the proposal, you have that, you mean?
Yes.
Okay. Yeah.
In our prototype, we already implemented this.
But I mean, in the spec, we need to get that in.
Yeah.
Sort of, it should be okay, but great.
Yeah. I mean, right now this is kind of within the OVSCNI configuration, so specific for OVSCNI. If you want to generalize and lift it, then it needs to be represented in different ways. I agree.
Yeah.
All right, we are over budget on time. I have to drop. I'm going to try to end the call in such a way that people can continue the conversation.
Let me thank you all for listening and providing valuable feedback. I hope that we can together find a good way forward with this.
+1. I think that we can too, and thank you for the awesome conversation and the presentation and participation for sure.
Thank you.
Yeah, sorry for hijacking the entire meeting.
No, that's great. This is one of my favorite meetings in a while, so I appreciate it.
Jan, where are you working? Are you at Ericsson?
Yes.
Okay, I'll Teams ping you.
Okay.
Just Jan Zurich at ericsson.com, right?
Yes.
Okay.
All right, thank you. Bye-bye.
Okay.
Yep.
Thank you, guys.
Bye-bye.
Bye-bye.
So did my voice go the wrong way? So what's going on? Why did I end up with Peter when I was calling Jan? That's interesting.